Yeah.
Okay. So what about ring is so for ring actually how it will be like there will be one centralized box will be there where the
Mhm.
centralized where actually we'll be connecting all our end hosts in that centralized box.
Okay.
Okay. Uh, it may look something like this:
Hmm.
A, B, and C. And all these
Mm.
systems again they'll have the NIC cards, which actually has a MAC address, right? The NIC card is the
The
one
network, the
interface
network cards.
network
Yeah, the interface
interface
cards.
card. Yeah, they
Card.
have the MAC address.
Oh, okay.
Okay, don't forget that that is a very basic one that we need to understand.
Mm.
This NIC cards actually they have the MAC address. When they have manufactured, by the time itself they have injected that particular address.
Address. Okay.
Okay, also this MAC address is called as physical address or burnt in address. Let me type physical address or burnt in address or layer 2 address. Why I'm
Mm.
calling this as a physical address means they are physically present. That means it is associated with that NIC card itself, right?
Net card.
That's why
Mm.
it is a physical address. Or why
Okay.
do we say it is a burnt in address? Means these addresses are burnt into that NIC card while in
So
the
you can
process of
change it.
manufacture. Yeah, in the process of
Mm.
manufacturing itself.
Mm.
And also, why I'm calling this a layer 2 address is in that OSI layer, they are in the layer 2 actually. I'll tell
Oh,
you
okay.
when
So
we are
it
talking about the
falls
OSI
in
layer.
the layer two cat. It falls in the layer two category.
Right, right.
Mm. Mm.
So if in this case A want to send some data to C, what happens is my data from A, actually what A does in that case, let me have the IP address 10 with the same example 001, and they have the MAC addresses AAA, and
Mhm.
B have 10.0.0.2, and they have the MAC address BBB, and
Mhm.
in this case C will be having the IP address 10.0.0.3, and they'll have the MAC address CCC. So when A is sending data to C, how it construct? So first destination IP address, which is 10.0.0.3, and then it will
Mhm.
put source IP address, which is 10.0.0.1.
Mhm.
Then it will put destination MAC address CCCC, and then it put
Mhm.
source MAC address AAAA. Then
Mhm.
actually it put the data.
Mm.
This is how actually it construct the message for C.
Okay.
When this data is being sent from A, it does not
Mhm.
directly go to C in the ring technology. First, it goes to
Okay.
B.
Okay.
Okay. Then it comes here. Then it will go to C. So it
So from A, it will go to the centralized, and then from centralized, it will go to B, and then from B, it will go to back to the centralized. Yes.
yes, right.
Right. Okay.
So physically it may look like this, okay, but logically how they look like is they are connected in some kind of ring fashion,
Mm.
right? Let's say that if I have here A, sorry, what is happening here? A, and this is B, and this is C.
Mm.
Think like it is connected to a ring,
Mm-hmm.
and here there is something called a token. It is some kind of memory space
Mm-hmm.
which keeps rotating in the speed of RPM in that ring.
Okay.
Okay, so this data, okay, there is a rule number one. If A need to send some data to somebody else,
Mm-hmm.
first he need to check whether the token is free or whether the token is occupied with any data. If
Right.
the token is free, then only he can put his message. Otherwise, he cannot put any messages on the token.
Right.
This is the rule
So he's
number one.
always checking. with the centralized to make sure there's a gap, free gap before he can send the message out.
Right. So let's say that now A got a chance and there is no data in that, so it put this particular message in the token. This tokens
Mm-hmm,
keep rotating now. Okay. So
mm-hmm,
when this token comes here, what B does, actually it is rotating in such a speed, so he cannot actually hold the token for some seconds to handle or process the data what it is there. So what actually B does, it copy the data from the token to its memory,
mm-hmm,
okay, whatever it is there, and it checks the process. Okay, how it checks, what it checks, first it check the destination MAC address is good.
mm-hmm.
No, it is not good. Why? Because B's MAC address is BBB.
BBB.
There,
Mm-hmm.
there itself there is a fail. So just discard that message.
Straight away. Okay.
Okay. So when this token comes here, now it's a turn for C, right? So in the
Mm-hmm.
same way, what C does actually,
You will copy
C
it and
actually
check it.
copy the data to its memory,
Mm-hmm.
right? So now see what it looks. He'll be looking into the
The
destination MAC
destination.
address.
Mm-hmm.
It pass.
Mm-hmm.
Then what it do? Then it check the IP address whether it pass or not.
Mm-hmm.
Yeah, again it pass. Why? Because he's the one ten
Mm-hmm.
zero zero three.
Mm-hmm.
Then now he looks for the data.
Mm-hmm.
Okay. So now keeps the token keeps running. Now actually what C does now? So now he'll be restructuring that payload. How? Now the destination address become 10001, who was source before,
Mm-hmm.
and now the source address will be 10003,
Mm-hmm.
and destination MAC address will be AAA, and
Mm-hmm.
source MAC address will be CCC,
Mm-hmm.
and instead of data there will be a acknowledged data will be there.
Okay.
Okay. So
Mm.
now the rule number 2, which is only the authorized receiver can change the data in the token. B cannot do any
Right.
change. Okay.
Right.
So the token message got erased and he put this particular message into that token.
Mm-hmm.
So when this token come here, now what A does, A will check what it is there in the token. Yeah,
Mm-hmm.
now first he'll check for the destination MAC address. It matches. Yeah.
So
Then
A
it
will
will,
do the same procedure. It will copy it first, check it first to see that it is him. Yes.
yes.
Right.
Right, exactly. So he check the MAC address, IP address, both get passed. Then he look into the data. Okay, it is great that C is acknowledged A data. So now
Mm-hmm.
it is rule number 3. It is A's responsibilities to clear up the token actually when he got the acknowledgement from the receiver,
Right.
so that
So
other in that media can start communicate with others.
communicating with others if they have something to send as well. Mm.
Exactly.
Mm.
So
So
this technology,
the
yeah.
difference between bus and ring is that with bus it will not only send it to the receiver but it will flood it to the others as well. Yes.
E-
Whereas ring it would have to check if it's free first before it can actually send the message to the destination. In the destination of all of them, each and everyone will copy it first to check if it's them before they receive it, and then acknowledge back to them as well.
Yes, exactly. But here there is no concept of tokens in bus, right?
I
It is
know, I
one
know.
physical cable. We are
Cable,
just
yeah,
yeah,
cycling, yeah, yeah, yeah.
yeah. So this technology where we are occupying, utilizing the tokens is called a token ring. Token ring.
Okay, token ring.
Okay. So if there is a break in this particular ring, nobody can speak with no one.
Right.
Okay. So to overcome this, actually, what they have done is they have made as a dual ring, something like this. Okay.
Mm-hmm.
And in the first case, actually, what I have told here is like the token start rotating in the anti-clockwise, right?
Mm-hmm.
In this case, this token will be rotating in the clockwise. So when this
Right.
ring detect there is some failure in this first ring, then this ring
Hmm.
will come into the picture. So that still they have the communication.
Right.
So with dual ring, this technology is called as FDI, FDDI, Fiber
Right.
Distributed Data Interface.
Okay. So the dual ring would do clock and anti-clockwise basically.
Both, yeah, for a redundant
Right.
mechanism.
Right.
So this is what token ring and fiber distributed data interface.
Right.
Okay. There any
Mhm.
questions in this?
No, it's clear.
Great. So now let's move to the star. Star is very simple, not that hard comparatively the bus and ring. Again, we have one centralized box where we need to connect our end devices. Again,
Mm.
we have A here. Again, B here. Again, let's say we have C, and in this case, we have some sort of cable to connect to that particular centralized box. And in this case, if A want to communicate, he don't want to depend on anyone. He directly send it to C.
Oh, so straight direct through.
Yes, if C want to communicate with B at the same time, he can send it to B through that box,
Mm.
centralized box.
Okay. Okay.
Okay, this is how actually our switch works.
Yeah, nowadays, isn't it?
Yeah, right.
Right.
So this is actually called a star topology.
Okay. But the star topology, does it not have like the ring and the bus where it needs
It
what you call
has
it,
a
MAC
issue.
address?
It has a caveats, but
Okay.
it is like the caveats are let's like I have three ports where I have connected. Okay,
Hmm.
if you face any issue with this port, only C will be affected, not A and B. Still,
Right,
they can have
right,
the communication.
right,
Okay, it is limited to that only that end host. That is what the biggest advantage actually with the star topology.
right.
Yeah.
Okay.
Okay. So this is what actually the different topologies that we can have in our network: physical topology,
Hmm.
logical topology, and there are multiple classification under the physical topology.
Hmm.
There is no such classification in logical topology. It is just an understanding how do they.
Yes, how it works.
Yeah.
So at the moment in the real world as we are now,
Hmm.
21st century, 2020,
Hmm.
is the bus and the ring and star still being used at the moment?
Actually, it was in use in my. I have around 6.5 years of experience. So when I started my career, I was seeing since the ring topology was used in some government
Mm.
sectors, but I don't think still the ring exists. This technology, whatever we
Right.
are speaking, everything is. Peculiar with Cisco platform. We are not sure about other vendors like HP or
Other
Dell.
vendors, okay. Yeah,
Yeah,
or Dell or Microsoft or things. Mm.
maybe they have with some kind of enhancement, but it may
Yeah,
not the same technology what they have used in the past olden days.
olden days, right, right.
Right. So that is the one difference. But
Yes.
you can only see star as of now. There are no ring or bus that you can expect within Cisco platform. Basically
Mm.
how we are connecting our network devices, that is what how it says actually.
Right.
Okay,
Yeah.
so can I start with OSI layers? It will take much time because there are 7 layers.
Mhm.
If you feel that today we have done, we have learned so many things, if you want some break, then we can continue this on tomorrow.
Me, I don't have problem. You're the teacher, so whichever one you think is best,
Because
you
my
let me know.
student don't want to be overburdened with all these things, that's why.
No, 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 no. I don't have problem. It's just, you know, You
Yeah,
are the teacher. You know, which route is best. What you think we do is going to be best for the day. You just tell me, and we learn, and yeah, we carry on.
great.
But the
So here,
OSI model, you said it's 7 layer, but
yes.
when was it? I think last week. I think I was watching YouTube,
Hmm.
and it's supposed to be 5 layers or something like that. TCP now
Four
with
layer, which is
with
TCP/IP.
yeah, which is the new because apparently there was one before. Um, there was the first one which was it six
Application
layer or
layer,
something, and
seven
then it
layers,
came,
four
yeah,
layers.
7 layers, and then it came 6 layer, and then 4 layer or something.
No,
Because
no,
over the years it's
seven layers
changing.
to 4 layers.
Oh, 7 to 4. Okay,
Yeah,
right.
basically they are not reducing the layers. Actually, they are combining the functionality of these layers into one layer.
1 layer, right, right.
Yes, yes. Okay. So first, to understand that, actually, first we need to see what is OSI layer. Okay, there is
Okay,
some short and sweet story behind this OSI layer.
okay.
Okay, don't get bored. It is something like storytelling.
No
Okay.
worries. Short and
So,
sweet is
okay.
nice. Everything that is sweet is good. So,
Yeah. So let's think about there is a one guy who is very much intelligent and he is running an office,
Mhm,
and also his friend have one office who is running where is the pencil? Yeah, he's running his own office. Even he's an intelligent guy, and
mhm,
he has some employees, around some 3 to 5 employees. They have their own beautiful, the olden
mhm,
desktop computers,
mhm,
and their job is like, if the person first person worked on some data that need to be passed to the second guy so that he can able to work, and if he done that job, he need to pass to some other guy so that he
mhm,
can work.
mhm.
So it was a hard time to exchange this data. By that time they were using the magnetic tapes, and then floppy drives, and then
Yes.
CDs, and the
Yeah,
USB
CD-ROM and all
sticks.
that. Yes.
Yes. So what this guy did, okay, every time this was consuming a lot of time and lot of
Money.
money, everything in place. So what he did, okay, let me find some solution for this. So what he did, he find some type of box with some kind of technology and some sort of cables to connect to their NPCs or desktops, whatever it is,
Mhm,
and now they can start exchanging their data without any problem or without any dependencies for that magnetic tapes or USB sticks or floppy drives or CD. Okay,
mhm,
now
mhm,
these friends are going for the some get together in some cafe, and this guy is just telling to him like, this was the case and I have come up with some new solution. Now my employees are happy with the solution and they are
mhm.
working.
So that
So
guy is like a vendor, basically,
not vendor, he's just friend, actually some kind of
a friend.
competitor or whatever it
Right.
is. Okay,
Okay.
so now what he think, okay, when he is able to do it, even I can able to do it. And what he did now, yeah, exactly, you got the point. Yeah, yeah, it is a vendor. Right, right, right. Right, I did. Yeah, right. So
Yes.
they invented their own products, and fine, now they are able to communicate in the same way. Okay,
Mhm,
let's give some name for them, like Dell
mhm.
and Cisco,
Yeah, or IBM, or yeah.
whatever it is. Yeah,
Yes.
IBM
Yeah.
or
Yeah. Yeah.
okay. So in olden days, there was an issue. Let's say that if I bought some switch from some vendor, and
Mhm,
if I want to go and purchase some router,
mhm,
some in, I don't want to buy some high efficient router,
mhm.
but that, let's say that some X vendor I got this switch. Okay,
Yes.
let's
Yes.
say that from
Something cheap.
Cisco,
Yeah.
yeah,
Mm,
something cheap. And when
mm,
I'm going to buy the router, again I am
mm.
dependent to buy from the same vendor. I cannot
Yes,
use
because
cross
otherwise it's not gonna
vendors.
work in it. Yes.
Yes, because this whatever the protocols they are put in place, only they can process with the data, how to process, how to deprocess everything. They knows that. Other vendor doesn't know
Okay.
what does it mean. So here, what the
Mm,
OSA came into the picture. Actually, OSI is developed by the standard called ISO. They have
Okay.
developed the OSI just in the reverse. Okay, so
Oh,
what they
okay.
have
So
done,
OSI ISO.
yeah.
What
So
does it
what they
stand
have,
for? Inter what?
international standard organization,
Right. International Standard
right?
Organization. Okay.
So OSI stand for Open System Interconnect
Open System Interconnection.
or
Okay.
Open System Interconnection. So IS actually what it has done, like he called up these two vendors. Hey guys, I know that you have done a very great job. If you can tell like few of the things that you have done to make this job done, so that we can make it standardized to
Hmm.
as a one product or one platform, so
Yes.
that everybody can follow that, so that
And use
everybody,
it. Okay.
yeah, use
Okay.
it.
Yes. Yes.
So I don't want your whole idea, but I want just some
Little
few,
bit.
yeah, little bit. Okay, if you want to make pizza, just the pan, what pan that you're using, something like that information. Okay, if
Mm.
you can give me that, then I can standardize the protocols and the method of communication, so that everybody can, uh, there is no, it is some what we call that,
Like no
vendor
competition, so that
vendor
it's
interoperability,
right.
right? Yeah,
Mm.
no competition. You can buy Cisco switches or Dell routers, still they'll
And you can use it
support
straight
it.
away.
Yeah, but caution is like they'll have their own features. They'll have their own features. Cisco that have their own features that native features won't be supporting in general.
Mm.
Still, right? But basic communication you'll get it.
Right.
Yeah. So this is what the OSI it is, and so OSI what it done, it has segregated the 7 layers,
Right.
basically like to which tells the networking device how they need to communicate from sender to receiver and
Right.
receiver to sender. So
So if that didn't happen,
mhm,
by now, 2020, technically every single company or every single vendor would have been making their own OSI model to work with their own product, isn't
yes,
it?
all
But
right,
then the problem then we would have had is you can't buy Dell product and use it on HP product. So then that would have been problem for the end users.
yes, exactly.
Right. So that's why they came up with one OSI model that works basic with everything, but then the features is what changes basically.
Right.
Mm.
So here there are the 7 layers. So starting from physical data link, network, transport, session, and presentation.
Hmm.
So the numbering should be always from the below. Okay, the
Oh,
layer one, if I say it is always a physical layer, you
so
cannot
it
consider
starts
layer one
from
as an
it starts
application
from
layer.
bottom up. Is that
Exactly,
what you're
bottom up.
saying?
Yes, right.
Oh, bottom up, not from top to bottom. Okay.
Yes, right. Okay. So in that case, actually, it is hard to remember that 7 layers. If you think there is some code words that you can just think of it, just you can memorize it, which was taught by some of my college professor. Please do not touch Sam's pet animal. Okay, either you can go with this or please do not throw sausage pizza away.
Okay.
Okay, that means P stands for physical layer, D stands for data link layer, N stands for network layer, T stands for transport layer, S stands for session layer, and P stands for presentation layer, A stands for application layer.
Right.
Okay, so basically, so first layers are always physical, second layers are always data link, third is network, fourth is transport, fifth is session, sixth is presentation, seventh is application. Being a network engineer, we'll be only working on these 4 layers. We don't
Right.
care whatever it happens with application, presentation, and session.
Oh, okay.
So what we have done is like we have segregated these 7 layers into 2 layers. One is upper layer, and one is a lower layer. Okay. So upper layer
Okay.
means application presentation session. Lower layer means a transport network data link and physical layer.
Mm.
So again, these each layer they have multiple protocols in it with multiple intention. So
Right.
why is that and what is that? Let me just cover that. So in application layer, you can think two different application. One is network application
Mm-hmm.
and one is non-network application.
Mm. Okay.
Okay. So basically, what is that network application? Non-network application means what is network? Network is something where the multiple end hosts are connected to share some resources, right? Whatever the available resources.
Okay.
So if you are able to send or receive any data in that application, right? That application is called as a network application, which is capable of communicating with somebody.
Okay.
So non-network application is such application where we cannot send or communicate with anybody. For example, here take a browser, whatever the browser it is. You're communicating with n number of remote servers like YouTube, Facebook,
Mm-hmm.
Google,
Mm-hmm.
right?
Mm-hmm. Mm-hmm.
And you can consider Outlook, where you are sending and receiving the emails,
Mm-hmm.
and something like that. You can consider Gmail, whatever it is,
Mm-hmm.
and
Mm-hmm.
also WhatsApp.
Mm-hmm.
For non-network application, what you can think it is something like this Paint, what I'm using,
Mm-hmm.
and something like WordPad or
Mm-hmm.
Notepad or the calculator, what I'm using in laptop or
Mm-hmm.
desktop.
Mm-hmm.
You can work on it. You can send this as an attachment over the email, but from this application, you cannot communicate with other persons, right? So that
Mm-hmm.
is why this application on non-network applications.
Right.
Okay. So basically, with this application, how we are able to communicate? There should be some things behind in background. It should be making ease of these operations, right? So what are they? So they are called the protocols. Those protocols will help us to communicate in certain manner how we want it. So
Right.
what are the protocols that we can say that are usually works in application layer? HTTP, which usually we will see in our web browser, or HTTPS, or FTP, or TFTP,
Mm.
or DHCP, or DNS. So all these protocols actually come under application layer.
Okay.
So what is the purpose of HTTP? To get the web pages, right,
Mm-hmm.
in a general way. What is HTTPS? Which in the secured way, right?
Secured way.
If you want to do some banking transactions, whatever it is, you can the
Mm.
secured means of communication. You can use it
So
HTTPS.
HTTP, what does that stand for? Hypertext
Uh,
Transport Protocol?
exactly.
And then Hypertext Transport Protocol
Secure,
secured.
right?
Right. Okay.
So this FTP is something file transfer protocol. Usually, uh, again, let me get back to our normal organization network where they have their router and switch and their NPC. Uh, uh, okay, and this is PCA and this is PCB and this is PCC. Sorry, okay, BC, whatever it is. And let's say that this is my FTP server. Okay, they all connected to this switch
Mm.
locally. And due to like this manager is bit conservative and he don't want to purchase high-end systems, he just given like with the space of 200 GB or 100 GB only with limited. They cannot actually store their file in their local PC if they want to do since they are running heavy application which already occupied that given space. So, but what he did, he gave one server if they want to use it for some storage purpose. That means officially if they want to use it. So what
So
they'll do, what kind of
what is what? So server. What is server?
okay,
Is
server.
because the difference between server and ISP is two different things, isn't it?
Yes,
Or
exactly.
is it the same?
No, server is again the PC only. You can consider something like a PC, but
Mm-hmm.
it is something more powerful than the PC.
Okay.
Okay, it can handle multiple requests and it can reply to the request. Okay, let me just draw a systematic pictorial topology. So these are the PCs, right? Or
Mm,
laptops, whatever it is. And
mm,
here I have my cloud. Basically, cloud means there is a router in it.
okay.
And also this means I have a switch here. And in
Mm,
remote, I have a router. And they have a switch, or maybe the server is directly connected to the router. That
mm,
really depend upon them.
mhm.
So think this is Google,
Okay.
and this is your environ. Okay, I need to draw one more router in this case. Think these two routers are connected. These two routers are connected.
Mm-hmm.
This is complete your office. Okay, ignore the
Mm-hmm.
circle. So what happens is like whenever the request is coming from
End users.
yes, right. Okay. Now let's say that this guy is requesting for Google web page. His request first come to
Mm-hmm.
switch. From switch it will go to router. This
Mm-hmm.
router will send it to ISP. ISP will
Mm-hmm.
forward know where is Google and he'll forward to that Google's router,
Mm-hmm.
and from Google router it will go to Google actual server. This is server. Actually where that
So
HTTP
this so
protocol
that's
is
like
running.
the actual engine.
Yes, right.
Right. Okay. Now I get it. Because
Actually how is
I thought the server is part of the ISP, but
no, no,
it's
no. They're
different.
not
Okay.
part of the
Okay.
ISP. It is
Okay. I
something
get it.
similar to that PC, but they are more powerful than the PC.
More powerful than PC, right? It can handle more work.
More work, exactly.
Yes.
He's like a
Mm,
Superman.
yes. Yes.
So, how this PC is communicating? What means communications happening from here to here is either the protocol like HTTP,
Mm-hmm.
okay, if it is a banking server, something like or a brokerage server, something like Charles Schwab or
Mm-hmm.
Morgan Stanley, then might be there will be you can see HTTPS, right? Wherever you
Mm-hmm.
do transaction which need to be secured.
Mm-hmm.
So based on these protocols, the servers will understand. If let's say
Mm-hmm.
that if this server is intended to work on HTTP protocol,
Mm-hmm.
if the request is initiated with the HTTPS,
Mm-hmm.
this communication won't
Secured.
happen. This communication won't happen because the server
Oh,
is not intention to work on HTTPS. He'll only respond when there is a request with the protocol HTTP.
okay.
You cannot access the bank service with just HTTP, right? It will automatically redirect you
No.
to HTTPS. Why? Because they are
Yes. Secured.
intended,
Yes.
right? So that is
Yes.
what it is. So in the same
Mm.
way, actually, what I do, mm, shit, where it is? Okay, I have a router and I have a switch and I have multiple PC here, and also I have some server locally associated with my organization. Okay, so the server is no, it is within my organization, which is locally connected to the switch. And to
Mm-hmm.
reach the server, I don't want to go outside the internet to access this server. Within LAN, I can able
Mm-hmm.
to access them, right?
Right.
So in my case, what I have told that that CEO has just given this computer to the employees with a limited storage
Mm-hmm.
purpose. So these employees, if they want to save or store some of their data, which is huge in size, what they will do is
Mm-hmm.
like they will utilize this server for storing
Okay.
or retrieving a data.
Right.
So this server now it is named as a file transfer protocol server FTP.
FTP.
TP, yeah,
Okay. File
file
transfer
transfer
protocol.
protocol server.
Protocols. Okay.
It is something similar to HTTP. You think why? Because it is
Yeah.
not that secure. Okay,
No.
if I want to do secure, then there is something called TFTP, Trivial
TFT.
Transfer File Protocol.
Trivial transfer file protocol. Okay.
Okay. So
Mm-hmm.
this is actually we'll use this, the FTP servers, whichever it is there in our in our network. Maybe the server is I have shown in the simple way. It is
Mm-hmm.
located within the same organization, like connected to the
Yes.
same switch.
Yes.
Maybe if let's say that Google is not only situated in US, it has so
Mm-hmm.
many branches in the world, right? They'll have
Mm-hmm.
multiple servers in their different parts of their location.
Mm-hmm.
So still those servers are considered to be locally connected in terms of Google network,
Mm-hmm.
right? Okay, don't get confused. We'll be familiar with this once we
Mm-hmm.
started
Mm-hmm.
moving ahead. So that is what actually this many protocol actually it is there in that application layer protocol. And what is this DHCP is a dynamic host configuration protocol.
Dynamic host configuration protocol.
Okay. Uh, so we have studied about two different types of addresses. One is like MAC address and one is like IP address, right?
Mm-hmm.
So
Mm-hmm.
MAC address is something is stable, which we cannot change it technically. We cannot change, but we can do change if you want to be a hacker to hide your identity. Okay, so tomorrow you
Right.
should not think, okay, Durai did not teach me that we cannot change the MAC address. Okay, so technically it is not, we can change that to hide our identity, but
Mm.
it is the unique MAC address which is we
MAC
cannot
address to
change.
every device, so it cannot be
Yeah.
changed. But you can hide
Yes.
it to
Yes.
do other things.
Okay.
Yes.
Yes. Right. So in that way, IP addresses I have told like it is something that we assign to that PCs, right?
Mm-hmm. Mm-hmm.
So let me show you that here. CPL. See here, there is some kind of addresses that we have specified, right?
Mm-hmm.
So these are the IP address that we actually manually we will be assigning to the PC.
Mm-hmm.
Okay, so these addresses can be okay. We can assign it either manually or dynamically.
Okay.
If there are some one PC or two PC or maximum 10 PC, yeah, if I want you to assign IP address manually to that PC, you can do it. Why? Because there are
Mm.
only less number of system. If it is a
And yeah,
case there are 1,000 number of system and 10,000 number of system that you want to assign IP address, you don't.
that's gonna take you like 2 or 3 weeks.
Yeah, that depends, right? So in that
Mm.
case, actually, we need some protocol to ease our operation. So what actually we do is like go with dynamic host configuration protocol. What it
Mm.
does actually, okay, in this case, let's say that this server, let's consider this as a DHCP server.
Okay.
Okay, once you have enabled, if you click on that PC, in
Mm-hmm.
desktop, IP configuration is there, right? There are two
Mm-hmm.
options. Either you can manually put IP
Static,
addresses
which is
statically.
static, yes.
Yes,
Mm-hmm.
right. Or you can click
And
on
dynamic.
DHCP. See here, it started requesting the IP address to whom?
Oh, so
To
it's
its,
doing it automatically.
yes, right, IP address. See, it
Right.
got the IP address. Great. We
Right.
haven't configured any DHCP since, but still it got
Right.
some IP addresses. Okay, this is
Okay.
something called APIPA.
A paper.
Okay, what does it mean? Like when the DHCP server fail, in a network,
Mm-hmm.
temporarily we'll get some IP addresses. We are not saying no
Oh,
to
so
anyone. We are having such a big heart. We are giving at least something to them. So something like
so
that.
it keeps changing. Then it's not permanent.
Yeah, it is
So
not permanent.
the static one is permanent, but the a paper one will keep changing. If it fails one, it changes another.
See, APIPA is something when DHCP, when the host not able to communicate with the DHCP server. By that time,
Right.
there is something called APIPA. Okay, these address range are fixed. The host will be assigned in that address range with some IP address.
Right.
Okay, see, APIPA is being used. Okay,
Mm-hmm.
so in this case, if I configure this as a DHCP server, all this hand host will be getting that IP address what I have configured in this particular DHCP server in that same
Mm-hmm.
network. Okay, I'll show you in upcoming classes how to do that.
Mm-hmm.
In our classes, actually, we are not going to do with the servers, but
Mm-hmm.
actually
Hello.
we'll make our hello.
By the way, class going to be end in 5 minutes.
Okay, fine.
Am I even
We'll
ready?
be yeah, not a problem.
Okay.
So what we will do is like we will make this router as a DHCP server, and the
Mm.
IP will be assigned from the router to all the end hosts.
Okay.
That is what how we will be doing in our classes. Okay,
Okay.
we'll see that, and this is what that I want to do. I want to just tell you about the application layer. Basically, in this application layer only we are start initiating the communication. If
Mm.
there is no browser, if there is no application layer, we cannot communicate with anyone
Mm.
because there is no browser and there is no these protocols are used.
Mm.
Okay, this is where we start communicating with our end users.
Mm.
So again, similarly, we have so many protocols and so many functions with the several layers. I think we
Mm.
can continue this by tomorrow or in our upcoming sessions.
No problem.
Okay, I just want to give some relief to you, not to get overloaded.
But
Uh,
it's good. I'm enjoying it. It's making more sense to me now.
yeah, great. I appreciate that your involvement in this.
Because when you're watching YouTube video and this thing, it's too quick. You don't understand what they are saying. Then they're talking quick, 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 quick.
Yeah,
But
yeah,
now it's making more sense because we're going one by one, so it's making more sense
right.
of what they do and where they sit. Mm.
Yes, right. So, okay, John. So, when we are expecting to meet next?
Today's Saturday, isn't it?
Yeah. Meanwhile,
Yeah.
if this communication got disconnected, just get engaged with Abdul. He'll be helping us, okay, to
No problem.
meet.
No problem.
Okay,
So
thanks, Abdul.
I'll talk to Abdul.
Yeah,
I'm hoping I haven't received my itinerary yet, but I'm sure I'm going to receive it this evening if I'm working tomorrow. If I'm not working tomorrow, I'll tell Abdul so we can schedule for another session. Okay.
sure, John. Great.
All right.
So
And
have a good rest.
I'll talk to Abdul and then now I'll sort out the
Yeah,
payment
Sure,
as well.
sure.
we will be in touch.
Thanks,
Okay.
John.
All right.